Bismillahirrahmanirrahim. This is our first online lecture of microeconomic analysis. I deliberately kept it very short. It's a lecture of about 15 minutes. Based on your suggestions, we'll try to improve the next lectures. Thank you very much. In last two classes, we discussed a case of utility maximization. We took utility as the objective function subject to the budget constraint. Since it was a case of constraint optimization, therefore we worked out the Lagrangian function. From the Lagrangian function, we worked out first order and second order conditions of utility maximization. The first order condition of utility maximization was that the ratio of marginal utilities should be equal to the price ratio of commodities. We already know that the ratio of marginal utilities is the marginal rate of substitution, which is the slope of indifference curve, and the price ratio is the slope of budget lines. So it means that the first order condition revealed that at equilibrium, the slope of budget line should be equal to the slope of indifference curve, which is just as that at equilibrium, the budget line should be tangent to the indifference curve. Now we can see from the figure that the first order condition gave two different scenarios, one where the indifference curve is concave, two where the indifference curve is convex. For this we need the second order condition. The second order condition revealed that at equilibrium we need convexity. Therefore, the second scenario where the indifference curve is convex to origin is the equilibrium point. After working out the first order and second order conditions of utility maximization, we worked out utility maximizing demand functions. The utility maximizing demand functions are obtained through the simultaneous solution of first order conditions, and these demand functions are the functions of prices and given income. So they're also known as money income held constant demand function or ordinary demand functions, and they are well known as Marshallian demand functions. So we saw that Marshallian demand functions are the functions of prices and given income. After uh, discussing the derivation of Marshallian demand function, we discussed the three basic fundamental properties of Marshallian demand function, including homogeneity, angel aggregation, and coordinate aggregation. We also discussed the implication of these three properties. After that, we finally talked about the Lagrangian multiplier lambda, which is the rate at which the optimal value of the objective function changes as a result of change in the constraint. So in our scenario, the objective function is utility and the constraint is income. Therefore, lambda is the rate at which utility increases as money income increases under the optimal conditions. So this is what we have already discussed. Today we will discuss the concept of indirect utility function, but before going into the idea of indirect utility function, let's once again recall what the ordinary utility function or the direct utility function is. Utility, we already discussed, is the function of commodities. So the utility function is the function of commodities. We have restricted ourselves to two commodities. However, there can be n number of commodities in the consumption plan of consumer. So in our scenario, utility is the function of x1 and x2. We have assumed that x1 is the first commodity and x2 is the second commodity. So the ordinary utility function is the function of commodities. So it's defined over the consumption set and represents the consumer preferences directly. Okay, now let's talk about indirect utility function. Starting with its basic definition, the indirect utility function takes utility as a function of given prices and income. The definition is written on the slide. You can clearly read it, that the indirect utility function takes utility as the function of given prices and income. Now let's try to understand it. We know that utility is the function of commodities, and commodities, which are the utility maximizing demand functions, are the functions of prices and income. So utility is the function of commodity and commodity is the function of prices and income. So indirectly, utility is the function of prices and income. Okay, now let's talk about the derivation of indirect utility function. Indirect utility function is simply obtained by substituting the corresponding Marshallian demand functions into the ordinary utility function. Look at the slide. We have the utility function. Utility is the function of x1 and x2. What is x1? x1 is the Marshallian demand function. What is x2? It's again the Marshallian demand function. x1 is the function of prices and income, and x2 is also the function of prices and income. So what we'll do, in place of x1 and x2, we'll substitute the corresponding Marshallian demand function. So substituting Marshallian demand function in the utility function will yield indirect utility function. So see in the slide, we have done it. Utility is the function of x1, which again is the function of prices and income. It's the function of x2, which is again the function of prices and income. So this is the indirect utility function. So eventually we saw that utility is the function of prices and income. Therefore, the indirect utility function is eventually a function of prices and income. Now look at the last blue shaded definition. The indirect utility function takes utility as a function of given prices and income. This is what we have already discussed. Let's focus on the second line. Indirect utility function shows the maximum level of utility achievable against the given prices and income. Okay, now keep this thing in mind, that how the indirect utility function is obtained. It is obtained by substituting the utility maximizing demand functions into the ordinary utility function. So, since we substituted the utility maximizing demand functions into the utility function, therefore the indirect utility function shows the maximum level of utility achievable against the given prices and income. Now we are going to take one example to understand that how indirect utility function is derived from the utility function. The utility function is equal to u x1 square x2 square, and the budget constraint is m is equal to p1 x1 plus p2 x2. Since it's a case of constraint optimization, so we worked out the Lagrangian function as shown in part 2 of this slide. From the Lagrangian, we worked out the first order conditions, which are reflected as equation 1, 2, and 3. From these three equations, we'll work out the Marshallian demand functions. The working of Marshallian demand functions is shown in part 3 of this slide. You can see that first we took the ratio of equation 1 and 2. From there, we got x1 as a function of x2, which is equation 4. We substituted 4 and 3 to get the x2, and then x2 was substituted back in equation number 4 to get x1. So finally we got x1 is equal to m over 2p1 and x2 is equal to m over 2p2. So these are the Marshallian demand functions. Now in final stage, we will substitute these Marshallian demand functions in the utility function, which is shown in part 4 of this slide. Now you can see in part 4 that the utility function is equal to ux1 square into ux2 square. In place of x1, we substituted m over 2p1. In place of x2, we substituted m over 2p2. And then after simplification, we got m power 4 divided by 16p1 square into p2 square, which is the indirect utility function. And it's clear from here that it is the function of prices and income. So once again, I'm repeating it, that in order to obtain indirect utility function, we have to substitute the Marshallian demand functions into the direct utility function. So this is all about indirect utility function. Now here we have one practice question for you. This is the Cobb-Douglas utility function. In previous example, we took the Cobb-Douglas type utility function in which the parameters alpha and beta were set equal to 2. But this is a generalized case where we are not setting any fixed value of alpha and beta. So now you are advised to work out the Marshallian demand function for this utility function and then the corresponding indirect utility function. In order Next lecture, we'll talk about the properties of indirect utility function. Till then, it's Allah Hafiz, and I'm waiting for your suggestions to improve the online teaching system.